Thank you, sir, for your valuable insights. Join us in welcoming Himabindu ma'am to the stage for the presentation on AI and ML techniques and applications. She will be sharing insights from the paper number 43 titled Unveiling Hidden Topics in Autobiography of a Yogi using the text BERT.
Good afternoon, respected dignitaries and learned scholars. I am Himabindu. I am research scholar of Department of Statistics, SV University, Tirupati. Today, I am here to present before you my work on the most interesting areas of NLP, which is topic modeling. So, this is my work. It's an application of topic modeling. It's an application of topic modeling on a book called Autobiography of A Yogi. I think many of you already have gone through that book. But before applying this technique on that book, I didn't go through that book. I applied it and then I cross-checked after applying that, and after getting the topics from that book, and I have gone through that book and I confirmed that my algorithm means I got exactly almost good results only. Means my topics are almost they are all there in the book. My algorithm worked well. This is what is my conclusion. So here is my work. As I told you already, this is application of topic modeling on a book called Autobiography of a Yogi, and there are many existing topic modeling algorithms. I applied a BERT topic. BERT topic is the recently developed package of topic modeling. I tried this BERT topic on, it's a neural topic model. I applied it on my book. So I got interesting results, and I am very much satisfied with all those results because I cross-checked after getting the results. I cross-checked. So therefore I can say that BERT topic has given, it worked very well for topic modeling. So I am able to get all the gist of the book in the form of the topics. And therefore we can say that topic modeling can be used not only for getting the topics from news data or like editorials of various newspapers. Apart from that, we can even apply the topic modeling on literary works like these books, so that without reading that entire book we can get the idea regarding that book by getting the topics from it. What is there in that book, the gist of the book we can get easily, so that the reader can decide whether if he is interested in such kind of topics he can go through that, otherwise he need not. So that is the use. And actually I got motivation for this work being a person with having a fascination about reading spiritual books. I got suggestions from my friends, relatives, whoever have read that book. They suggested me to read because I am interested in reading such spiritual books. But somehow I could not read. So after that, when I thought of reading that book, many well-known persons, not only many well-known persons, they read that book and they suggested, undoubtedly, whoever are reading that book, they are suggesting that book to everyone else. I don't know the reason. So I just thought of reading that book. At that time I was working on that BERT. So I thought, why don't I apply that BERT topic on this book to get the topics. So I applied. This is actually the motivation for that book. These are all the people, not only these, many other famous personalities have gone through that book, and they suggested everyone to read that book. So this is the book written by Paramahamsa Yogananda. He is a great spiritual master. So it is his autobiography actually. So coming to topic modeling. So as I told you, if I have a very large collection of data, if I have very large collection of documents, it's not possible to go through those all documents to get the gist of that, or whatever are the various whatever are the various topics covered in that. I may not do it manually because it's a large collection. So in that case, I can go for topic modeling. This is one of the NLP, machine learning techniques, NLP techniques, which works on textual data. It is used to get the topics from various topics from the given collection of the given corpus. Corpus is the collection of all the documents.
Say
So,
in case of the published documents,
yes, sir. Already there will be.
keywords will be there.
Yes, sir.
And index also will be there in book.
Yes, sir.
Even in this book, index will be there at the back.
Ah.
All topics are listed with page numbers.
I didn't take the index, sir.
I know you are not taking it.
Yes.
What I am saying is,
Yeah.
when I wrote a book,
Yes.
they asked me to make an index also.
Yes, sir.
So every book will have index.
Yes.
So this book also must be, I don't know if it has or not.
Yes, sir.
So if the index is there, then what is the need for topic one?
If index is there, see, we can.
Index
Yeah.
may not be there for newspaper articles.
Yes, sir. Even for some books, it may not be there. Yes, sir. So in that case, it generates, based on the keywords, it generates the topics, it divides the data into topics. In that case, it will be very much useful for us. Without reading the book, we can decide. So this is topic modeling, which is used to get the topics from your data when the data is very large, text data. So here is the process of topic modeling. This is my collection of data. This will be the actual input. It's a collection of a big collection of documents. Initially, that will be pre-processed. The data will be pre-processed for. There are many steps again in data pre-processing, which is not required for BERT topic. I am applying an algorithm called BERT topic. It's basically based on BERT. Bidirectional, as sir said, bidirectional encoder representation for transformers. So based on that BERT, a package called as BERT topic has been released recently. So we applied that BERT topic, and this BERT topic doesn't require any data pre-processing because it is context dependent algorithm. See, like there are many other algorithms, there are many other topic modeling algorithms where they require data pre-processing. They are context independent, means they completely remove all the punctuation marks, stop words, everything they remove. They require that data pre-processing, but this is context dependent algorithm. Based on the context, based on the previous words and the next words of that word, it decides what kind of word it is. Will it go to topic 1 or topic 2 or topic 3? Therefore, context is required for this. Therefore, no processing is required. Data pre-processing is not required here. Data pre-processing step will be there for other topic models. And then we apply the topic modeling technique. Topic modeling technique has to be applied. So after data pre-processing, we will apply the topic modeling algorithm, that particular topic modeling algorithm, and then as an output we will get the topics, and in place of the topic modeling algorithm we applied the BERT topic now. So it is about the BERT topic. So it is based on that BERT, and BERT is developed by Google it's developed in 2018 for contextual understanding of unlabeled text. When we are searching something in Google, like 2-3 words when you type, you will be able to see the next words. It projects the next words. That is because of, for that purpose, to get such prediction only, they generated that, they developed that BERT technique, and based on that BERT topic was developed recently, and this is a topic modeling technique which is based on BERT only, and TF-IDF, class based TF-IDF. We will see that. I'll try to explain that in the next slide regarding that. So this is about the BERT topic, and this is a methodology of BERT topic. Initially, the input, which is our corpus, that will be given. In the first step, in step 1, it will be represented in the form of vectors, embedding representation, and then those embeddings means those vectors. As a result of step 1, we will get the vectors, numerical vectors for our text, and those vectors will be given to step 2. In step 2, what happens is dimension reduction, because at the end of step 1 we will have vectors which are like based on our input text. The vectors may be of a very high dimension. With that much high dimension vectors, clustering becomes very difficult. Therefore, we have to reduce the dimension. So in the second step, dimension reduction will take place, and after different techniques we use for embedding representations, dimension reduction and all. Basically, I am telling you what is happening in each step. And then in the third step, these reduced dimensionality reduced vectors will be clustered based on the semantic similarity between them, and then from those clustered embeddings we will try to extract the topics, and that extraction once again involves some more steps.
Is embedding representation for every word or what?
It's yes sir.
For every word?
Every word with every other word it compares and it gives. Yes. So this is the visual overview. The starting step, the first step is embedding step, and then dimensionality reduction, and these are the default steps are same: embeddings, dimensionality reduction, clustering, tokenization, then weighing scheme, and then fine tuning, that is optional. And by default BERT uses sentence transformers for document embedding. Last step, first step is SBERT, means that sentence transformers, it uses sentence transformers. There are many sentence transformers. We can apply any one according to our use case for getting that embedded representation. We use that all-mini LM L6V2. It is already there in that SBERT sentence transformers. Apart from that, this is by default BERT uses this. Apart from that, there are many other ways, like we can use various frameworks like Spacey, Hugging Face Transformers, Flare. All these frameworks can be used to get the documentation, embedding representations. Anything we can use. This is about document representation. So I am talking about this step first. SBERT we used, default is SBERT only, and in that there are many language models. For multilingual there are many. We used that all LM. This one we used. All mini LM we used. For different languages there are different transformers. We can use them. If I want Telugu text to be modeled, if I want topic modeling on Telugu text if I feed, it will do it. So SBERT transformers, there is a special transformer for that we can take. So depending on our use case we will take. So I am talking about this step now. After that, the dimensionality reduction. By default it is UMAP framework it uses, the BERT uses UMAP framework. Apart from that, we can use principal component analysis for dimensionality reduction, for reducing the dimension of the embedded vectors. Then truncated SVD, all these we can use, any one of these we can use. Default it is UMAP. And then this is the step I am talking about right now. UMAP or PCA or truncated SVD, anything you can use, we can use. And then the third step is clustering. After that, after reducing the dimensionality, we will try to cluster the documents. The clustering is
Not documents, but the embeddings.
embeddings. Yes, sir. So by default, it uses hierarchical DB scan. Apart from hierarchical DB scan, we can use many other clustering algorithms, agglomerative clustering, k-means clustering. Agglomerative is available in scikit-learn library. We can use HDB scan is by default. So it tries to cluster the embeddings.
It will automatically do, no?
Yes, sir. It is by default. It is HDB scan. It automatically does it. If we want k-means or something else, we have to include that code in that place. There is a possibility, sir. So after that, the tokenization can be done once again in like it depends on our depending on our use case. We can go for count vectorizer or POS. Anything. Count vectorizer is scikit-learn library. It is very popularly used vectorization algorithm. We used count vectorizer only, and based on this is the place where once again some may be interested in 2 grams, some may be interested in single words, 3 words, combination of 3 words, 4 words, and so on. I took 2 words. Based on our requirement, we will take them. So when with the default settings only, we applied the BERT topic algorithm to this. We didn't change any. With the basic default settings only we applied, and we got the results, fruitful results only. So these are some topics I got. The topics which I got, I displayed here. Some of the randomly I selected some topics, I displayed the topics there. And then the gist of all the topics. By default, it created hundreds of topics. It is not possible for us to go through all those hundreds of topics. So therefore, so we can club according to the semantic similarity between the topics which are generated. We can club them, and therefore we reduced it to 41 or 42, nearly 42 topics, and therefore we got 42 topics. The gist of the topics I presented there.
Who does the clubbing? Clubbing you are doing or you are back
We will parameters we have to adjust, sir, according to like based on the results. Again and again we have to check that number of clusters, number of topics. By default it generates some. If we don't want those many, we can reduce it, or these many only I want, that number also we can specify.
Keywords or topics?
Topics only, sir.
Keywords and then
No, sir. Topics. In those topics, in each topic we will have words, keywords, with some probability. Highest probability words we will have in each topic. Sir, I will present those topics, gist and probabilities I have given as links, but they are not getting opened here. I will show you in my laptop, sir. Randomly I presented some topics over there, and the gist of all the topics and the probabilities I presented there. So these are the bar charts generated for the first 12 topics. We can see some keywords for each topic. In the first topic 0, astral beings, body, physical, casual, based on the probability, based on the semantic similarity and their probability, it displayed. The 12 topics we displayed here, and then these are all visualizations. We can get a better idea if we look at the diagram. Therefore, we generated many different types of diagrams to interpret, and these are documents inside the topics. And this is CV measure. This is the metric we used to decide whether our coherence score, this is the coherence score, we got it as 0.3781. It is it is used for, it tells us whether how far our topics are reachable to the people. So we got it as 0.3781, and there is no like this much only we have to get 0.51, there is no range for that actually. It depends on the once again use case. So this is heat map. So the conclusion is the conclusion. Yes, sir. Yeah. Similarity matrix, sir. With one topic with another topic. For all the topics with all other topics. Similarity.
You know what is topic cloud?
Topic cloud. Word cloud.
Word cloud.
Yeah. Yes,
Could
sir.
you generate that?
I didn't generate in this, sir. Previously, while in my previous paper using LDA, I did it. Latent Dirichlet allocation with LDA I did, and at that time I did. I didn't do that here. So here is the topics mostly. They have given us various themes like power of meditation, guru-disciple relation, and nature of consciousness, yogic approach. All these many different key themes we got as our topics, and we can say that application of topic modeling on literary works really helps for book readers before reading the book in its entirely. We can decide whether that book is suitable for us or not just by looking at the topics, and it is applicable even on literary works also, that we can say. Thank you. And as a future work, we can in each step by default BERT uses some mechanisms. We can apart from those defaults, we can use any of the other architectures also. Yeah. Thank you.